Hello students, welcome back to maths class. So we are dealing with the integral problems by partial fractions. So when we have to go for this method means in the denominator, suppose you are having linear factors, then you have to resolve the problem into partial fractions. Problem means the question into partial fractions, then you have to apply the integrals for that. Okay, so come on, now we did one method in previous class. In that all linear factors are different. If we are having in the question all different linear factors, each linear factor we have to take one fraction. Suppose linear factors are repeated, then how we have to resolve? So now we are solving that type of problem. So actually you will get all these methods in your 2a partial fractions. When fraction is given like this, all linear factors are differently, then how we have to take the partial fractions. If any linear factor is repeated, how we have to take, and instead of linear factors, suppose irreducible factor is given to us, how we have to resolve. Okay, so come on, now we will solve this problem. Evaluate integral x square by x plus 1 into x plus 2 whole square. Okay, so come on, you take x square by x plus 1 into x plus 2. This linear factor is repeated 2 times. This one we have to find. So before finding the integral, right, so we have to resolve this into partial fractions. So how we will resolve means x square by x plus 1 into x plus 2 whole square is equal to, for each linear factor I said you take one partial fraction. So for this x plus 1 we will take one fraction a by x plus 1. I said how we have to take the fraction, upwards we have to take some constant by that linear factor. Next, plus here it is repeated 2 times, no? So first time we have to take b by x plus 2. Next time we have to take c by x plus 2 whole square. Okay, this is the procedure when we are having repeated linear factors. Okay, if we have repeated linear factors, we have to take like this, 1 time, 2 times. Suppose here cube is there. Suppose I am saying, suppose here instead of square cube is there, then I will write one more term, d by x plus 2 whole cube. Like this we have to take. Okay, if repeated linear factors are there, like this we have to take. So in our question we are having only up to square, so we have to take like this. So it is repeated 2 times, no? You will get 2 fractions. So how in the first fraction it comes only once, in the second fraction it comes twice. Suppose cube is there, we will go to another fraction, d by x plus 2 whole cube. Okay, this is the condition when the linear factors are repeated. In previous problem, all linear factors are different and not repeated. So for each linear factor we have taken one fraction, isn't it? But here this is different, but this one is repeating, right? So it is repeated 2 times. So for first time we have to take b by x plus 2. Only one time we have to take in that fraction. Next partial fraction we have to take c by x plus 2 whole square. Suppose cube is there, then we have to take a plus d by x plus 2 whole cube also we can take. Okay, so that is the procedure. You consider this as equation number 1. Okay, so then try to get this ABC, that is called resolving the fraction into partial fractions. After getting ABC, we will substitute in this equation. Then your value fraction is resolved into 3 fractions. So that's why it is called resolving into partial fractions. Okay, so how we will get ABC values here? So x square by x plus 1 into x plus 2 whole square is equal to taking the LCM. So what will be the LCM? X plus 1 and x plus 2 whole square will be the LCM. And here x plus 1 is there, in the LCM x plus 2 whole square is also there. So we have to multiply a into x plus 2 whole square, okay, plus b into, come on, this is x plus 2, okay, but we are having x plus 1, x plus 2 whole square, only one time it is there. So you take x plus 1 into x plus 2, okay, plus c into, come on, x plus 2 whole square is there downwards, but in the LCM we are having x plus 1 into x plus 2 whole square. So it is c into x plus 1. So x plus 1 into x plus 2 whole square, x plus 1 into x plus 2 whole square, cancel. This is your second equation. Now from this second equation, try to get your ABC values by substituting suitable x value. So if we take one x value, so that the two values A, B, C are there, three values we have to find. So if we substitute any x value, two values will get cancelled and we will get third value. Like that we have to select our x value. So come on, suppose if I want to get a value, B and C should cancel. So how we can cancel B and C values? If I take x is equal to minus 1, what happens? Minus 1 plus 1, 0, 0 into C, 0. Here also C, minus 1 plus 1, 0, 0 into something, 0. So your B and C will get cancelled and you will get your A value. Like that we have to select our x value. So come on, put x is equal to which value? Minus 1 in second equation. Okay, so then what happens? This is this side, left side, minus 1 square, x square is there, right? A into minus 1 plus 2 whole square plus b into, come on, minus 1 plus 1 and here minus 1 plus 2, okay, plus c into minus 1 plus 1. Okay, so then what happens? Minus 1 square means it is 1. Okay, so a into 2 minus 1 is 1, right? So 1 square plus b into, what is this? 0 into 1 plus c into 0. So 0 into c, 0, 0 into anything, 0. Right? So 1 is equal to 1 square is 1, 1 into a is a. So a is equal to 1. Okay, so actually plus 0 plus 0 implies a is equal to 1. Okay, now you put your x is equal to minus 2, right? If you substitute your x is equal to minus 2 plus 2, this will get cancelled, this will get cancelled. Okay, you will get your c value in equation 2, right? In equation 2. So what happens? This side, left side, x square is there. So it is minus 2 square is equal to a into, come on, in x place, minus 2 plus 2 whole square plus b into minus 2 plus 1 minus 2 plus 2, okay, plus c into minus 2 plus 1. Okay, so this minus 2 plus 2, what happens? 0, right? 0 square. Here minus 2 square, minus into minus plus 2 square is 4 is equal to a into 0 square. And here this is plus b into minus 1 minus 2 plus 2, that is 0, plus c into minus 2 plus 1, that is minus 1. Okay, so 4 is equal to a into 0, right? 0, same thing, 0 into any times if you multiply, it is 0 minus c. So what is your c value? C is equal to minus 4. So now we got our a value, c value, we have to get our b value. If you observe your second equation, there is no chance to substitute x value here, isn't it? X is equal to minus 1, we can substitute. X is equal to minus 2, we can substitute. So no further substitution is possible. Then how we will get our b value means, now from the second equation, just you compare the x square coefficients, right? Then you will get your b value. That means first you expand this equation. So from 2, so what happens? Your second equation, left side it is x square and right side a into x plus 2 whole square, a plus b whole square form. A square, right, plus b square, 2 square means 4, plus 2ab, 2 2s are 4x. Okay, so this is with a into, okay, next plus b into, come on, how we can multiply? X into x, x square, right, plus x into 2, it is 2x, plus 1 into x, x, plus 1 into 2, 2, okay, plus, come on, we can write that is c into x plus 1 only. Okay, now comparing the coefficients of x square on both sides, right? So we can write this as x square coefficients. If we write, what happens? It is a, right? Here we will get b. Okay, next x coefficients, if we take, what happens? It is 4a, right? And here 2x plus x, 3x. So plus 3b plus c, x coefficient. Next constants, constant is 4a plus 2b plus c. So we have taken this equation in ordered form. Right. So here x square coefficient is 1. So equate the coefficient of x square on both sides. Is equal to is there. So we can equate. Right. So equate the coefficient. Right. Coefficient of x square. Right. You give any equation, till now 2 equations are over, so you take that third equation. Equate coefficient of x square in third equation. So here x square coefficient is 1. Coefficient means its multiple, right? So and here x square coefficient is a plus b. Already we got our a value. What is our a value? A is equal to 1. You substitute it, right? So what happens? 1 is equal to 1 plus b. So what is your b value? 1 minus 1 is equal to b, implies b is equal to 0. Okay, so your b value is 0. Therefore, from 1, what I said, once we got all our values, we have to substitute. That is called resolving the fraction into partial fractions, isn't it? So come on, from 1 we can write our x square by x plus 1 into x plus 2 whole square is equal to a by, a is 1, right? 1 by x plus 1. Next plus b by, b is 0, right? 0 by x plus 2 plus c, c is minus 4, plus of minus, minus 4 by x plus 2 whole square. So now we resolved the fraction into partial fractions. Now we can apply the integral for this problem. So therefore integral of this x square by x plus 1 into x plus 2 whole square is equal to integral of 1 by x plus 1. So it is 0. 0 by something is 0. No need to take that value. So plus of minus, this is minus, right? 4 by x plus 2 whole square into dx. Okay, so what happens whenever we are having plus minus signs, we can take the integrals, isn't it? So it is integral 1 by x plus 1 into dx. Next, minus 4 by integral 1 by x plus 2 whole square into dx. You know the formula, it is standard formula. Integral 1 by x plus 1 is nothing but log of x plus 1 minus 4 into, how we can solve? Same thing in differentiation or integration. Power is there means we have to take x to the power of n form only. So, but downwards is there. Then also power can be positive or negative. So, we can write this as x plus 2 to the power of minus 2 into dx. So, it is of the form integral x to the power of n. Right. So, integral x to the power of n is x to the power of n plus 1 by n plus 1, isn't it? So, is equal to, it is log of x plus 1 minus 4 into, come on, x plus 2 to the power of minus 2 plus 1 by minus 2 plus 1. After the completion, we have to write plus c, but we have to simplify, isn't it? So, is equal to, its value is log of x plus 1, right, minus 4 into x plus 2 to the power of minus 1 by minus 1 plus c. So, minus of minus plus. So, it is log of x plus 1, right, plus 4 into x plus 2 to the power of minus 1 plus c. Again, this can be written as log of x plus 1 plus 4 by x plus 2 plus c is the answer of your question. Okay, so actually in resolving the partial fractions according to the given question, we are having different methods. If linear factors are different and not repeated, then for each linear factor we have to take one fraction, right, in the form of some constant by that linear factor, and we have to find all those constants. Then we have to apply the integral. That's what we did in our previous class. Now today's class, you got one linear factor is repeated. So we are having repeated linear factors. X plus 2 is repeated 2 times. Then how we have to take the partial fractions means, first one is different. So for that we have taken one partial fraction. Next, after that we got the linear factor repeated 2 times, no? So for that first one, the fraction by that linear factor 1 time. Next, fraction, some constant by that linear factor 2 times. Some constant by that linear factor 1 time. Some constant by that linear factor 2 times. Suppose cube is there, then we will take one more term plus some constant d by that linear factor 3 times we have to take. Okay, so first time only constant by that linear factor. So it is repeated 2 times, no? Next we have to take some constant by that linear factor 2 times. Suppose it is repeated 3 times, then we have to take some constant by that linear factor 3rd time. Okay, so after that try to get your ABC values. How we will get ABC values? take the factors, cancel them. Okay, after that we have to select x value. Here a, b, c are there. If we substitute one x value, a and b cancels, we will get a c value. And if we substitute another x value, your c and a cancel, we will get b. Like that we have to select our x value. Okay, so after putting x is equal to -1, we got a value. After substituting x is equal to -2, we got a c value, but no further substitution is possible in our equation 2. In such cases, what we have to do, just we have to equate the coefficients of like terms on both sides of that equation. So this side you are having x square left side of your equation 2, right? So try to write this equation also, x square term, x term, constant term, so that we can compare the coefficients of like term on both sides. So here your coefficient of x square is 1, here your coefficient of x square is a plus b, right? Equate them, is equal to is there in between this equation, isn't it? So just equate the coefficients of x square in both sides. Then you got x square coefficient is 1, x square coefficient is a plus b. So a plus b is equal to 1. So already we got a value, substitute a is equal to 1, then b is equal to 1 minus 1, 0. Once we got a, b, c, in the first equation we have to substitute. Then for that we have to apply the integral. So inside the integral, minus plus sign is there, we have to take separate integrals. I have taken, at the end we have to write plus c. So then if any simplification is possible, simplify it. Till no further simplification, you have to simplify the answer. Okay, so be careful, be attentive. So actually, whenever in the question in integral problems you are having linear factors in denominator, you have to do it, you have to go for partial fractions. But again in partial fractions, all linear factors are different, or any linear factor is repeated, or any irreducible factor is there, then method is separate to resolve them into partial fractions. First resolve them into partial fractions, then you apply your integral, right? Then you will get your answer. Okay, so tomorrow if any irreducible factor is there along with the linear factors, suppose one irreducible factor is there, how we have to resolve it, then how we have to solve that integral problem, tomorrow we will discuss. Okay, so practice this problem perfectly. Okay, that's all for today. Have a nice day.